Good morning, students. Today we are going to see about the second topic in fifth unit called Z parameters. So last video, that is your first lecture video, we are seeing that two-port network introduction, right? So we just revised the previous lecture. So in as per your first lecture one, we are seeing the two-port networks. So can you remember what is the word called port? Yeah, port is nothing but a pair of terminal in which voltage or current can across be connected, clear. And two port is nothing but we are having two voltage v1, that is v1 and v2, and current is two current i1 and i2. And are you remember the diagram i1 and i2? So this is the diagram. We inside we just write a two port network. And this how many pair? Can you remember? Two port network having four dot, nothing but two pairs. So connect the dot from network, and here also dot to the network. And here plus minus voltage V1, and definitely this will be plus minus V2. And the current. One current is entering means definitely the second current will be leaving. This will be called I2 and this will be called as I2 dash. And as per KCL, we can tell that I1 equal to I1 dash and I2 equal to I2 dash. And two important two mark we saw. Do you remember two things? One will be a symmetrical and second will be a reciprocal. Two important two mark question. What in a symmetrical network? A symmetrical network is consist of, it will be same. That is, it is a mirror image of second of. It is mirror image. The first half will be the first half will be the mirror image of second one. And for this reciprocity, the passive networks, that is a network which are all obeys reciprocity, we call it as reciprocal theorem, reciprocity. And then example, all passive networks belongs to reciprocity, and all the active networks will belongs to the non-reciprocal theorem. And main thing we are saw the six parameters, right? So can you remember what are the six parameters? The first one based on that four letters, that is v1, v2, i1, i2. This four letters we can make this one into a okay, clear. Now, four letters and combine into two equations. So 4C2. How many combination? Yeah, it is 6. Can you tell me that will be the 6 combination? 4, 5, 6. So the first one, second, third, 4, 5, 6. So let it be. What is the first one? That is the combination will be V1, V2, expressing in terms of all the six letters combination. I1, I2, or else V1 I1 and V2 I2, and what are the last possibilities? V1 I2 and I1 V2. So all the four letters will be having this type of combination: V1 V2 I1 I2, V1 I1, V2 I2, V1 I2, and I1 V2. Clear? And what is the name of this V1 V2? Yeah, Z parameter. I1 I2 Y parameter. V1 I1 A B C D parameter. Other name is transmission parameters. And here V2 I2 we call it as it is opposite, right? So it will be the inverse transmission: A dash B dash C dash and D dash. And this will be your hybrid, and finally it was the inverse hybrid, or it is called a G parameter. So these are the four concepts. So today the second lecture is about your Z parameter, third lecture is about Y parameter, fourth will be ABCD. So these are the four lectures coming up soon. Okay. And now this video is all about, this is a revision of your lecture 1. Now I am going to take the Z parameter. So take your circuit analysis note, put the heading Z parameters. Z parameters. Or you remember what is the name of Z parameter? It is having two names. One we call it as a impedance parameter. Z letter we call it as a impedance parameters are open circuit. Open circuit open circuit parameters. So these are the two types, two names of your Z parameter. And the same way, if it is Y parameters, this letter is called admittance and this letter we call it as a short circuit parameters. Clear? And the next step, can you remember the expression and in terms of the Z parameter always is represented in terms of V1, V2, and in terms of I1, I2 you are having the equation. So you are having using the letter Z. So what is the matrix number? Z11 plus all the equations having plus except ABCD. Very good. Except ABCD, all the other combinations having the plus symbols. Z11, Z12, Z21, Z22. And now the letters V1, V2 is over. So what are the two letters is remaining? I1 and I2. Yeah, very good. So Z11 I1 and here it is I2. The same way it is I1 and I2. You can represent in this way, that is equation format, or you can represent it in as usual matrix format. V1, V2 will be equal to, here what is the letters? Z11, Z12, Z21, Z22 into what is the combination? It is multiplied with I1 and I2. Okay, this is a combination. Now you can write the equations, that is the value of Z11. So see, there will be the four letters Z11, Z12, Z21, Z22. So before going to start the problems, we must know the details, that is we must know the information about this matrix Z11. So always impedance as per Ohm's law, Z equal to V by I. So what is actually impedance? Impedance is nothing but the resistor. While it is, if we are talking about in DC domain, we call it as a resistor. When we call it as in a AC domain, we call that one as a impedance letter. So impedance is nothing but it is a combination of either R plus JXL or R minus JXC. Clear? And okay, V by I. This all are impedance. So letter will be V by I, V by I. Now what is the suffix number? So it is 1 1. So 1 1. It is 1 2. So here it is 1 and 2. It is 2 1. Yeah. 2 1. It is 2 2. So 2 V1 by I1 is Z11, V1 by I2 is Z12, so same way, clear? And all the things we are, what is the other name of Z parameters? Open circuit. So I1 is there means definitely I2 is equal to 0. This is the condition. Here I2 is present, so which is 0, I1 equal to 0. And what about here? Definitely I2 will be equal to 0 and here it is I1 equal to 0. So all this four combination we make current make a open circuit. That's why this other name is called open circuit parameters. So let us the name of each and every matrix. There will be the four names for each and every matrix. The first one we call it as a driving port impedance. Driving point impedance at all are 1 1, right? So that's why it is our driving point impedance at port 1. And this one second name is transfer impedance. Transfer impedance can be used for all other four parameters only when it is having the suffix number 1 and 2. So see here it is having the combination 1 and 2 and here it is 2 1. So if there is changes from 1 to 2 or 2 to 1, we call it as a transfer. Transfer from one port to second port or second port to first port. That's why it is called transfer impedance. But here see, listen, the first and fourth one, it is having the letter 1 1 and 2 2. There is no transfer, right? So that's why it is a name called driving point impedance. It is 1 1 means fourth one. So can you tell me the fourth one name? Yeah, driving point impedance. Driving point impedance at port 2. Clear? These are the information about your Z parameter. So let us revise one thing before proceeding the problems. So we start with your lecture Z parameters. It is other name called impedance and open circuit parameters. We have the equation and we have the matrix format, and each and every matrix we are having the formula and the name. Z11 means 1 1, V1 by I1, making I2 equal to 0. All the four combinations we are making, see, look at this, all the four we are making current equal to 0. When current is 0, when it is in open circuit, clear? That's why it is also called open circuit impedance. Okay, now we start the first problem. So actually Z parameter, if you have to be expert in Z parameter, you can solve some more problems, clear? Let us take the first one. So take your note and solve it, clear? No need of calculator, it is very much easy only. The first question name is determine what parameter are you understand? Determine Z parameters. So you are going to find the Z parameters. Z parameters means we are going to find all the four letters 1, 2, 2, 1 and 2, 2. They are not mentioned. You itself just understand. Determine Z parameters for the network. Copy down the note. Don't miss each and every sum. Each and every sum gives a different idea. So the sum will be, the network will be like this. This is a question. This resistor is 5 ohm. This resistor is 10 ohm and this will be a 20 ohm. And current will be going here is I2 and this current is called I1 plus minus V1 and here plus minus V2. Clear? Can you tell me the sum belongs to a reciprocity and symmetricity? Yeah, definitely it belongs to a reciprocal. Why? Because this is a passive network containing RLC. So that's why it follows your reciprocal theorem. But when we connected the current source and voltage source, it became an active network. So it doesn't obey the reciprocal theorem. And second sum is symmetricity. See, the first half will be 5 and 20. Second half will be 10 and 20. So it will be a asymmetricity property. Clear? Okay, now we are going to find out the four problems and see the current direction. This will be like flow in this direction. Let it be I1. I1 current will be flowing in this direction, but here I2 see it is not flowing in a clockwise direction. See the current. So this diagram will be like this. Are you understand? The current name will be I2. Clear? Look at the difference. In normal loop equation from unit 1 to unit 4, we see all the current flow will be in clockwise direction. But the fifth unit and that to port network, the last will be flowing in the anti-clockwise directions. Clear? So now we can write the two equations. How many loop will be formed? Two equations. Two loops. So for mesh 1, active element will be equal to passive elements. Active element name is V1 will be equal to 5 into I1 plus 20 into, in general we are writing as 20 into 1 minus I. So see whether it is correct or wrong. It is wrong because I1 is flowing in clockwise direction. If I2 is flowing in clockwise direction, this equation is correct. But here the I2 will be flowing in anti-clockwise direction. So it means it will be become plus. A small change. This is the difference from fifth unit. This is the unique difference from all the four units. Okay? And second, this is the first equation. And for mesh 2, you just tell me what is the equation. Active element equal to passive element. So V2 will be equal to 10 into I2. 10 into I2. And also see the traveling. When traveling, we are seeing the second symbol. It is from minus to plus. So definitely it is V2. 10 I2 plus 20 into what letter? Domination. You are writing the mesh 2 equation. So I2 I1. Whether minus will come or plus. Yeah, it is plus because opposite direction. Clear? Now we are having two options. One thing we make I1 equal to 0. Second thing I2 equal to 0 for both the equation. When I1 equal to 0, what you are getting V1 will be equal to I1 0. This is 0. So only you are getting 20 I2. So from this we can get V1 by I2. What is V1 by I2? V1 by I2 is 20. And what is the name of this one? Z1, 2. So it will be 1 and 2. Clear? Huh? Now coming to the next one. Can you write the equation? I2 equal to 0. So see, in this equation put I2 equal to 0. V1 will be equal to 5 I1 as it is come. And here it is 20. But I2 is 0. So finally you are getting 25 I1. So finally you are getting Z with the suffix number V1 by I1. That is the answer you are getting 25. So the name is V1 Z11. Clear? And now coming to this point. We are having this equation. V2 will be equal 20 I2. Now you make I1 equal to 0. I1 equal to 0. What you are getting? V2 equal to 10 over 20. So totally you are getting 30 I2 and I1 is 0. So therefore V2 by I2 will be equal to 30. The name will be is 2. Clear? Because the suffix number. And make I2 equal to 0. When I2 equal to 0, we are getting what answer? See, V2 will be equal to 10 into I2. So 0. Only you are getting 20 I1. So V2 by I1, we are getting 20 and the name of that is Z21. So finally you are getting all the four letters. See, Z12, Z11, Z22 and Z21. So we are getting the all the four answers. That is your question because all the four equations. So finally you can make the write all the answers in Z11. This is the place of Z1, 1, 2, 1 and 2, 2. So answer for Z1, yeah, 25 and this will be 20 and Z21 will be your 20, Z22 will be your 30. Clear? The first sum is over. Now take the second sum. This Z parameters also having another question like verify the reciprocity and symmetricity property. If the question will be asking like this. So after finding all the Z parameters, they are asking reciprocity and symmetricity property. Remember the reciprocity. Z12 will be equal to Z21 and symmetricity equal to what the formula? Z1 equal to Z22. Can you tell me Z12 will be equal to Z21? Yeah, 20 equal to 20. But what is Z1 is 22. If it's not that, so we can property. From seeing the question itself, you can tell that it is containing C. One of will containing 5 and 20. Second will and 20. So definitely it is a asymmetricity property. So two more question. Now taking the second sum. The second sum in a network, copy down. So don't miss, just your note and write. Take it casual. In a network, Z1 will be equal to angle 0. That is they given in a polar form. Z2 will be equal to 5 angle minus 90 and Z3 will be equal to 3 angle 3. Find Z parameters. The Z parameter as all the four members Z11, Z12, 21 and 22 and the diagram they gave like this, a box, because it is not a resistor. They are given in terms of impedance. Impedance is nothing but the combination of resistor and inductor or resistor. So that's why they are given the box and name this one will be Z1, Z2 and this will be Z3. As usual the voltage V1 and here plus minus V2, the current flow will be I2 and this current flow will be I1. Clear? So now as usual equation I1, but here not clockwise, it is anti-clockwise I2. Clear? And there is a two method. One method you can put the value and proceed, or else you can keep as it is Z1, Z2, Z3. Finally you can substitute the values. And before proceeding, you can think angle 90 can be represented as J and angle minus 90 can be represented as minus J. Clear? Okay, now start the problem. So any loop will be there. So there will be two loops. So first one, mesh 1. Mesh 1. Can you tell me the equation? Active element V1 will be equal to Z1 I1 plus Z3 into I1. What is the symbol? Yeah, plus I1 plus 2. And for mesh 2 equation, active element will be V2, passive element will be equal to Z2 plus Z3 into I plus I1. These are the two equations. Now as usual, put I1 equal to 0. Getting V1 will I1 by I2 will be equal to Z3, that will be Z12 will be equal to. Next, I2 equal to 0. What you are getting? V2 will be equal to Z1 plus Z3 into I1. So V2 by I1 will be equal to Z1 plus Z3. The name will be 2 and 1. Clear? And here, as you should put I1 to 0. You are getting V2 will be equal to Z2 plus Z3 into I2. So V2 by I2 will be equal to Z2 plus Z3, and this name will be equal to Z22. Clear? And finally the last one. What is the missing number? I2. I2 will be 0. Get the equation V2 will be equal to Z3 I1. So V2 by I1 will be equal to Z3, and this will be called as a Z21. So we are getting all four. Right? V2 by I1 here also. See, it is V1, right? Sorry. It is V1 and it is V1. V1 by I1. Z11. Clear? So, okay. Z11, Z12, Z21, Z22. So, your answer Z11 will be Z1 plus Z3, and Z1 Z3. Z21 is Z, and Z22 is Z2 plus Z3. It's a reciprocal because Z12 will be equal to this number is same. So, theorem satisfied. And now you just substitute your the equations, that is Z value, Z2 value, Z3. So nothing but Z1 will be 2 and 0, and Z5 and minus 90, and here it is 3 and 90. So now you can write as 3 and 0, it is 5, yeah, minus 5, because angle minus 90. Here it is 3. Now substitute this equation. Z1 plus Z3. So 2 plus 3J is the first answer. And Z3 is same 3J. 3J is this also 3J. And here Z2 plus Z3. Z2 is minus 5 and Z3 is plus 3. So what answer? Minus 2J is the answer. Okay? Okay, we solved the two sums. Now move on to the third sum. Third sum. Question is find driving impedance. Find impedance. What indicates? Simply from previous two problem we see that Z parameters, right? But here it is find driving point impedance. So we know that driving point is Z1 and Z2 because there is no transfer, and also transfer impedance. So it is another parameter. Find the Z parameters means all the four. Here they gave two different names, Z12 and Z21. Okay, transfer impedance of the network and the resistor. And this value is 1 farad, and 3 ohm. As well plus minus, that is your 1 dash, and here is 2 dash. They given like this. Okay. Now you can change your question. And from before seeing that, we know one concept like difference between your 1 port and 2 port. In 1 port, it can be solved by using Thevenin and Norton's theorem, and in 2 port network, it can be solved by S domain. Clear? So previous, you can solve like a previous problem. You keep as it is 1 farad and 3 ohm. And now this problem I can go with that Laplace transform because S domain. This is a 2 port network. So you can rewrite the equation capacitor followed by the resistor. In S domain, resistor as it is plus minus V1, and here plus minus V2. Current will be like I1. This current will be your anti-clockwise I2. Capacitor representation. Capacitor is 1 by S. The value is 1 farad. So therefore 1 by S, 1 by S. This is your equation. Now you can start with that problem. So how many loop equation is possible? Yeah, two loop mesh 1. Can you tell me the equation? V1 will be equal to 1 by S I1 plus V into I1 plus I2. This is your one equation. And here mesh 2. What is your equation? V2 will be equal to I2 by S. That's 1 by S into I2. That's why 1 by I2 by S plus 3 into I2 plus I1. Yeah. Now coming to the equation, 1 by S plus 3 I1 plus I2. So we can write 1 S plus 3 into I1 plus I2. V1 will be equal to, and here it is V2 will be equal to 3I1 plus 3 plus 1 by S into I. Clear? Now as usual, two steps. Put I1 equal to 0, I equation. So now I am putting I1 will be equal to 0. What you are getting, V1 will be equal to I2. So sorry, it is 3I2. So don't forget 3I1, 3I2. So 3I2. Therefore, V1 by I2 will be 3 and here will be Z1, 2, 1, 2. Yeah? And here put I1 equal to 0. What do you think? V2 will be equal to 3 plus 1 by S to I1. So Z21 will be equal to V2 by I1 equal to plus 1 by S, or else 3 plus 1 by S. Yeah, this is your top. And second of I2 will be equal to 0. What you are getting, V1 equal to the same 1 plus S, 1 by S 3 into I1. The final Z1 will be equal to V1 by I1 will be equal to S plus 1 by S. And over here I2 equal to, and you are getting V2 will be equal to V2 will be equal to 3I1, 3I1. The second will be 0. Therefore V2 by I1 will be equal to 3, and the time will be 0, 1. See, Z1 2 is 3 and Z2 1 is, so it is a reciprocal theorem is satisfied. So finally the answer is you can write it Z11, Z12, Z21, 2, clear? And so and Z11 is S plus 1 by S, it is 3, it is also 3, 3 is plus 1 by S, clear? See, Z12 will be equal to Z21, Z1 will be equal to 2. This is a condition for L and this is the condition for simplicity. All are verified. Clear? And now we see the different one more sum. Now clear? Okay, now we can start the fourth sum. Determine driving point alone. Driving point network. Can you tell me how many? Yeah, Z1 and Z2 is Z. No need to find all the four members. And the question will be having in how this will be a yeah, will be 2 dash 1 ohm. This is 2 Henry and this is 2 Henry 1 ohm 1 dash. Yeah, this is the now you can change your question into our 2-port network, that is insert your voltage source and current source. Yeah. And before going to this, it is having the one more extra branch. Previously we are having like this number, like a T-shaped question, but here it is a pi-shaped question along with the one inductor. So now tell me resistor connected in parallel. So you can make it as a single branch. So for resistor and I am having a because this box is nothing but over 2 Henry, that is 2s parallel with 1 right in Laplace transform. So it is 2s and it is 1. If it is a capacitor, you can write as 1 by 2s. That is a capacitor is in denominator. And if it is inductor, that is we already know now L equal to that is R plus JXL we can write this S into L. If it is capacitor, we can write SC. Yeah, that is our name. Okay. Now again read out the diagram. Yeah, resistor, and this combination. Yeah. What is the letter when 2s is parallel with 1? What is the answer you are getting? Yeah, 2s. My numerator will be a multiplication, denominator will be a addition. 1 plus 2s. 2s divided by 2s plus 1. And this value will be a 1 ohm, and this value will be of 2s. Yeah. And now you just connect your plus minus V1, and here it is plus minus V2. And the current flow. This current flow we call it as a I1 current, and this is in between you are having current that is called I2. Sorry, always this will be your I2 current, right? So this will be your I2. This makes I3. Yeah. So totally in the sum we are having three currents. Currents will be I1, I3. See, I1 and I3 will flowing in what direction? I1 and I3 flowing and I2 will be flowing in and direction. Yeah? These are the things we are going to be understand before starting the problems. Yeah? Okay, now three equations. So mesh 1, can you tell me? Source will be V1 will be equal to 1 into I1 and I3, but it is both are in clockwise direction. We can write I1 minus I3, and be careful, it is not plus because I1 and I3 flowing in same flow, same direction, and that's all. And coming to your mesh 2, see what the characters, three characters is involved. So first no active, so 0 will be equal to 1 into I3 minus I1. As per mesh 2, third current is 180 plus 2s into what? 3 or 5. That big 2s by 1 plus 2s. Tell me the current direction. See, here it is present in between the two current called I3 and I2. I3 flowing in clockwise, I2 flowing in anti-clockwise. Now tell me the equation. That is opposite direction. So it is I3, I2. Once you're strong in this current equation, you can solve any problems. Yeah. And now last equation. Mesh 3. Mesh 3. What is the equation? Source active will be followed by only one character, 2s divided by 1s, and your I2 and I3 the symbol. I2 and I3 flowing in opposite directions plus. That's all. So you are getting three equations, and then you just substitute all, put I1 and I2 equal to 0 in all the three equations. Use all, then you can get, yeah, put I1 equal to 0 and I2 equal to 0 in all the three equations. All the three equations. So finally you are getting, at last they are asking only, just it is a homework for you, and they are asking only Z11 and Z2. That is asking find impedance. So I'm writing the answer, you just proceed. Yeah, and this answer will be 4 square plus 4s divided by 2 1 whole square plus 2s, and here Z22 will be equal to 2s by plus 1 by 4s square plus 4s plus 1 divided by 2s plus 1 square. Yes. Can you solve this problem? Okay, you just try by yourself. That is nothing but put I1 and I2 equal to 0 in all the three equations. That is I1 equal to 0 in mesh 1, mesh 2, mesh 3. You are getting the equation. and I2 equal to 0 in same mesh 1, mesh 2, mesh 3. So you are getting sixth equation. With the help of the sixth equation, by substitution method, by you can eliminate any one letters, then you can guarantee till like that Z11 and Z22. Just try. Clear? Okay. Okay, ma. So today up to this is over. It's sufficient. It is called Z parameters. So next class we can see about the Y parameters. Thank you. And before that, we can start with we can revise the sum because so many things we studied now. So first thing we have started with the Z parameters. Z parameters, other name is called impedance or open circuit parameters, and we are writing the equation format as well as the matrix format, and we give the name of all the four members, and we are taking the four sums parameter and nothing but we are equations, loop equation, and writing making one to be a zero, making any one current equal to zero, and we are getting all the four letters. And one more important concept is both the current. If the current flows in the same direction, means you are putting I1 minus I2. But here it is little bit different. I1 is current. See here, I1 current is flowing in clockwise, means I2 current is flowing in anti-clockwise. So opposite current means you are using the symbol plus. This concept you will never forget. This is the main thing. Yeah. Okay. Thank you. Solve that sum. You can start continue in the next video. Yeah. Thank you.